Welcome back to part 2 video. So we'll solve a problem on friction force. So generally I'm going to solve a problem which has very real practical example rather than the problems we usually solve for ITJ preparation. So one of the problem is that, for example, let's take that this one auto rickshaw guy. Okay, sorry for my image nonsense. Okay, and he travels from A to B, right? Now 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 he wants to know what price he should charge in order to get the 20% margin on the cost he occurred from A to B. Exclude the labor cost, okay? And petrol price is, let's say, 100 rupees per liter, okay? And the fuel efficiency of the vehicle, assume 20 kilometer per liter. Now, for one person, let's say the seating capacity is 3, okay? So what should be the price of one person from A to B? And the distance between A to B is 20 kilometers. Now think it's a very practical problem. People generally think that if you tend to load more, the fuel will cost more, but they can't relate why it is costing more. I mean, is it because of heavy load? But the load is on the ground. It's not pulling vehicle, in opposite direction. So it comes through friction force. Since um, it depends on normal force, which is the downwards weight of the vehicle. So if number of people increases, the normal weight increases, thus friction force increases. So the retardation will occur to the push it gets from fuel. So in order to find out what should be the price, let's assume the price of one person, the charge of one person from A to B would be X, and there are total 3 people, right? And we need to charge 20% margin on cost. Well, let's assume we have to relate it with the cost. So 3 times would be 20 kilometer, and the fuel efficiency is 20 kilometer per liter. So in 20 kilometers it will need 1 liter petrol, and 1 liter petrol has a price of 100 rupees. So it will come as 3x is equal to 100 rupees, and x will come 33.33, which is roughly 34 rupees. So although I have not used the concept of friction force to solve this uh, numeric, but the theoretical aspect of why the we need to charge more if we are increasing people rather than, so it could come as if, for example, one vehicle is moving with one person from A to B in one scenario, right? With one person charging 100 rupees, and with 3 persons charging 30 rupees each. So in which scenario he'll have to, he's losing? So obviously scenario number 2, because his fuel expense would increase. I mean, it requires a total calculation. For example, let's assume the scenario 1, where he's moving with one person. Scenario 2, where he's moving with 3 people, charging 30 rupees. Here he's charging 100 rupees from one person. So let's say which scenario is more profitable. Okay. So if it's going with one person and weight comes around 100 kg of vehicle itself and 70 kg of the person, it becomes 170. Here it becomes 100 plus 3 into 70, which comes around 310, right? Now friction force will proportionate to this. That means acceleration would be proportionate to this. Uh, so let's say scenario one has acceleration 1 and scenario 2 has acceleration 2. The acceleration ratio would be proportional to the weight they are carrying. So I mean that's frictional force proportional. Again, the retardation acceleration proportional would be proportional to the mass it is carrying. So 310, 170, which we can take roughly around 2. So that way, whatever fuel it takes in scenario 1, let's say 1 liter, it will take 2 liter in the scenario 2. It will cost 200, here it will cost 100. So it's taking 100 from one person. So he's getting the break even. Here he's charging 30 rupees per person, which happens to be 3 into 3, which is 3 into 30, which is 90, and is getting cost of 200, right? So you can say is total loss in the scenario number 2. So this suggests that if you're carrying more person, you have to charge more. If you're carrying single person or less people, then you should charge lesser than what you charge normally. Thank you.